section 7.4 is actually going to be the last type of transformation we're going to talk about. We still have another section where we're going to kind of combine all of them, but this is the one we've mentioned already, translations. Now notice the title also throws in this word vector. All right, so we'll kind of talk about what this is in just a minute, but it involves translations, okay?
Yes.
And what exactly is a translation? It says a translation, a glide or a slide, you'll hear us say those things, is a type of transformation that maps, now how they word this, and we'll kind of explain a little bit, how they word it is a little bit
just like about
unusual.
an origin or in a plane, yeah.
It says it maps every 2 points. Now, you could map 1 point to another point or 3 points to another 3 points. In a plane to points P prime and Q prime so that the following is true. Now, these are kind of the criteria. So, they're saying, so P is your pre-image, right?
Right.
And your P prime is your image. Notice the notation. So, they're saying the distance from here to here is exactly the same as the distance from this other point, this is a pre-image, to its image. So, the distance from here to here, oh, it froze on me, sorry, and the distance from here to here have to be exactly the same for translation to happen. So there's one thing. And the other criteria says, so segment P prime, so this segment has to be parallel to segment Q prime. So these also have to be parallel for it to form the translation correctly. Or they said throw in, they are collinear, basically meaning they're the same line.
Right.
Okay. Now, the key about this, guys, is with a translation, when you glide or slide it, you're moving every single point the same amount in the same direction.
Right.
Otherwise, this criteria will not happen. So I tell my students every year, this is a slide, don't worry about it. It's more kind of the mathematical lingo, which is not always the most convenient.
Yeah.
Okay. So the key is that you want to make sure when you perform that translation, that glide or the slide, you're moving the same amount and the same direction for each of those pre-image points.
Right.
Okay?
And these things will just happen.
Yes, it will.
All right. So we've got a couple different notations we're going to take a look at today. And the first thing we're going to focus on is our coordinate notation. And a translation in a coordinate plane can be used describing what we call coordinate notation. And I want you guys to notice that we start with an x comma y.
And that's your pre-image, right?
Right. And we have an arrow. This arrow is just telling me how it maps. Okay? So this is describing the mapping.
So where it's moving to.
Where it's moving to.
Like how much and things like that.
Exactly. And then the next ordered pair, so to say, is a way to describe what am I doing to my x value, I'm adding so much, or what am I doing to my y value, I'm adding so much, in order to get to my image. You're going to notice that we've seen this really a lot already. We just didn't necessarily describe it as coordinate notation, where you're saying we've got an x comma y that's being mapped to, like, you know, when we looked at our reflections and our rotations, we saw this when we were coming up with those, you know, those what happens every time when I, for example, yesterday rotated every time 90 degrees or rotated 180 degrees counterclockwise. So it's just describing what's happening to that x comma y. That's what our coordinate notation is.
It's just describing it.
It's just describing
it.
But what you're going to notice when we're talking about a translation is that you're just adding or subtracting to your x and to your y values.
Okay.
Okay? So A is talking about the horizontal shift in this case because it's what I'm adding or subtracting to my x value.
So horizontal, if you were like actually moving it on a coordinate plane, that would be going left or right.
Exactly. So along the x-axis. And the B in this case is talking about the vertical shift because it's being added or subtracted to the y value.
So vertical would be going either up or down.
Exactly. So looking at this coordinate notation that they've given us in this example, it says that our x comma y, our original pre-image, is mapping to an x plus 4 and a y minus 2.
Okay.
So every point in this transformation that's happening here, in this translation, is moving which direction?
Okay, well, if it says x plus 4, that's the horizontal shift. So that plus 4 means you're moving to the right 4. And the y minus 2 is talking about the vertical shift, so that'd be going down 2.
Awesome.
So you're taking every point, and this coordinate notation basically is telling you what you're doing to every single pre-image they give you.
Exactly.
So you have to do the same right 4 down 2 for every single one. Otherwise, you're not performing the translation correctly.
You got it.
So let's actually do one. All right, so this one you don't have to worry about a line of reflection, and you don't have to worry about, a fixed point and how many degrees you're rotating. I think translations typically are the easiest for students.
Yes.
There's a variety of ways you can kind of do this. If they actually want you to sketch the image, then actually moving the figure right, left, up, down is pretty easy. There's also a convenient way, and I'm going to kind of stress that as well, without actually graphing. So let's say we're going to sketch it says sketch the parallelogram with vertices. They give you the vertices. We already have it sketched. It says now sketch the image of the parallelogram after a translation. And notice they give you this coordinate notation.
Okay.
All right, so here's the deal. When they ask you to sketch the image of the parallelogram, obviously you want to actually draw that, but I also want to know the coordinates, all right? For checking purposes, it's so much easier if you know what the coordinates are.
Yes.
So don't just sketch it. Give me, okay, what is R prime? What is S prime? What is T prime? What is U prime? So we want you to be doing that as well, so keep that in mind, okay?
Yes.
So what is this coordinate notation basically saying we're doing with every single point?
Every single point, that x minus 3, that's our horizontal shift. So that's telling me I want to move it to the left 3. And then the y plus 4, that's my vertical shift. So that tells me I want to move up 4. So every point I need to go left 3, up 4.
So if I'm starting at R, let's just start with the R because that's the first one. If I go left 3, 1, 2, 3, and up 4, 1, 2, 3, 4, this should be my R prime. So I'm going to go ahead and write down my coordinates real quick.
So it's at -7, 3.
Thank you for helping me there.
You're welcome.
Like my eyes aren't as good as they were when I was younger.
I think I have a better vantage point right now, too.
All right, let's do the same thing. We're going to do the same exact movement for every single pre-image point.
Okay.
So R or S, you're going to go left 3, 1, 2, 3, up 4, 1, 2, 3, 4.
So there you're at -5, 5.
-5, 5. All right. Let's go T. So left 3, up 4.
Okay, and so there you're at -4, 8.
And then same thing. Left 3, 1, 2, 3, 4.
And there you're at
U prime.
U prime. So it's at -6, 6.
And I'm going to, since they said sketch the image is actually a parallelogram, so I better see a parallelogram in the end. And what do you think is going to be true about those parallelograms?
They should be congruent.
Yes.
It should be an isometry.
Yes, it is another one of those isometries. Now, notice here, guys, this is a very easy way to do it by just counting, and I think a lot of students like to do that. Another way you could do it is you could, if they obviously didn't require you to graph, how could you use the coordinate notation to get these ordered pairs?
Yeah, it looks like I'm just taking whatever the x value was and just subtracting 3 from that x value.
So it's kind of like putting -4 in for x. So it would be -4 minus 3. That gets you the -7.
Right.
And then if I put -1 in here, -1 plus 4, that gets you 3. So you're basically subtracting 3 from every x coordinate.
Right.
That's the left 3 idea. And adding 4 to every y to get the y coordinate, the up 4 type deal.
Exactly.
So just something you can consider there.
Yeah, and if they don't ask you to sketch it, that's a great
But
shortcut
again,
to use.
stressing, guys, we need to see these coordinates,
Yes.
all right? Because when you start checking, we're not going to have the actual sketch there for you. We're going to have the ordered pairs because then it's an easy, quick way to check, all right? And you're going to be required to do that on a test as well.
Okay. So what we're going to do here is I have the pre-image and the image on your paper, and I want you guys to describe this translation using the coordinate notation. So we're coming up with what is the coordinate notation.
So it's kind of like the other one. It's kind of reverse of what we just did.
Yes, it's just working backwards.
And how do I know which one's my pre-image?
Good question. Well, you may be thinking red or blue, but
Yeah.
on a black and white sheet of paper, it's probably not going to come
gonna
out that nice. So what is it that we always make sure we put with our image?
Image has the prime symbols.
So we know that this figure up here, this red figure, this has to be my image because it has the prime symbols.
Okay.
So starting with the blue, moving to the red. Starting with the B, going to the B prime. Starting with the A, going to the A prime. Now, what does the coordinate notation always start with? What does it always look like when we
X
start?
comma Y. And then the little arrow to show maps to. So you got to start with that, right?
Have to start with that. Don't just give me the X plus or minus something and the Y plus or minus something.
Okay.
Make sure it's got the whole piece. All right, so what could I do to figure out, to get from A to A prime, what is that pattern going to be?
Okay, well, we could count.
We can count.
Okay, so I'm going to go, since I'm dealing with X first, I'm going to go left. It looks like 1, 2, 3, 4, 5. So that means it'd be X minus 5. And then I could go up 1, 2, 3, 4. So it'd be Y plus 4.
Now, could I check that with other points just to make sure that I've got that right?
I think that's not a bad idea.
So do I go 1, 2, 3, 4, 5
To the left.
to the left, and then up 1, 2, 3, 4 here?
It worked.
And it probably would work for C too, right?
Uh-huh.
1, 2, 3, 4, 5, and up 1, 2, 3, 4. Yes.
Now, another way you could do it, kind of going with the order pair idea,
Uh-huh.
let's say like C. Let's go to C. C is 0, 1. What are the coordinates of C prime? What's negative
5, comma 5.
So you could think about, how did I get from 0 to negative 5? Well, that means subtracting 5. And then to get from 1 to 5, I added 4.
So a couple ways to think about that. Awesome.
All right, now, coordinate notation, and Ms. Hoker even mentioned this, is that there's 2 ways to describe a translation. Coordinate notation was one. The next way, and we're going to get to in just a minute, involves component form. Now, the thing about either form, either way you're describing, it describes 2 things. It's going to tell you basically what direction and by how much.
Right.
That's really what a translation is, all right? Now, there is a word that involves this idea of a component form, and it's called a vector. Okay, now a vector is actually something you'll hear about even in physics. I remember taking physics class in high school and then in college. Vector was something you heard a lot. And notice the description of it. It's the quantity that has both direction and magnitude, or what we talk size. So think about it. With translation, you're going to have to tell me where you're going, direction, and by how much, the size. And it is represented by an arrow drawn between the 2 points. All right, so we're going to show you what that is in just a little bit.
Yeah, and looking at it, it looks like a ray. It's not a ray. And there's something we use to help make sure that we know it's not a ray.
Exactly. Now, tomorrow in class, we're going to show you a little clip that involves this word vector, right? And it's in a movie that you guys have probably seen.
And some of you may be already thinking about that. And we're going to leave it as a little teaser right now.
Yep. All right. Okay. So here's the deal. Every vector is going to have an initial point, which is your starting point, and a terminal point, which is the ending point. So this vector, the starting point would be point P, and the terminal or ending point would be point Q.
So notice that it's not a ray. It doesn't go through point Q. It ends at point Q. It just tells you which direction to be going.
Yeah,
which is your starting point, where are you ending.
Where you're starting and ending, and by how much, basically. Okay, now how you name this vector. How you name it with its 2 points, your initial point first, kind of like a ray, and your ending point, unlike a ray continues on. Now, because it's not a ray, the way you draw it, it looks like a ray.
Looks like half of a ray.
Exactly. That's a vector. So you get comfortable with that notation. All right?
Okay.
Now, all vectors are going to have 2 components to it. It's horizontal component and its vertical component.
Which is similar to what we did with coordinate notation as well.
So horizontal would be basically describing what?
How much you move right or left.
Okay, and then vertical would be
up or down.
So let's actually do that on here. So if I am starting at this initial point of P, how much am I moving horizontally to get to Q?
Okay, so let's see. There's 1, 2, 3, 4, 5, 6, 7. I'm moving 7.
And I move 7 to the right.
To the right,
so that would be just
7.
positive 7. And you don't need to put a little plus there. And to vertically, to get to that point Q, I'm going down.
1, 2, 3.
So that would be
negative 3.
Now, the way you actually write this other form, component form, which is what we're going to be using as well as coordinate notation as well. Component form basically combines these 2 things. Not meaning like actually add them together. It just, you're going to write it where it says the horizontal and then the vertical component. But notice the little notations. It's not a parentheses, because parentheses would mean an ordered pair. It's these little...
Kind of
like
a less than and greater than symbol. I know, that's what it always
little
looks
bracket type thing. So the horizontal component was 7, and then the vertical was negative 3. Make sure you don't put parentheses. That's a common mistake. Parentheses means you're telling me the ordered pair is 7, -3. Well, here's 7, -3. Well, that's not even dealing with this.
No.
Right? What this coordinate, and this is our component form, is telling you how much you're moving right or left, up or down, and by how much.
Yeah.
Okay?
Okay, so these are some vectors, and we're going to name the vector, and we're going to write their component forms. Typically, you're going to be given a vector, but we want to make sure that you guys are understanding what this is saying, too.
Okay.
All right, so let's start with CE. So, first of all, how would I name it?
It wouldn't be CE, would it?
It would not be CE. Tried to trick you there.
All right, so when you name it, you're going to name it with its initial point first, so E, and then C, and then with the little vector symbol above it.
Awesome. So make sure you always start with the initial point, the piece that doesn't have the arrow with it. All right, so we've got vector EC, and its component form, if I want to look at horizontal and vertical shifts, how much is it changing horizontally?
It goes to the right 2, so 2, and then up 1, 2, 3, 4, 5, 6.
So 2, 6. Now, again, it's not an ordered pair, so I'm not putting it with the parentheses. We're using that vector notation. Okay, what about M and K? How do I know which one to start with?
The initial point is M, and then K, and then the little vector symbol, and then the component form, I'm noticing it's only going to the right. So 1, 2, 3, 4, 5, 6.
So that's my horizontal piece. But what is my vertical piece?
There is no, so it'd be just 0.
0, good.
And the last one, I'm just going to name it. DF.
I don't have a good color for that. Okay.
And the component, or the little vector symbol. And the component form went to the right 1, 2, 3, 4, 5, 6, 7. And down 1, 2, 3. So -3.
Yes. Awesome. So we can name vectors. Now, frequently when you're going to be looking at these things, you're going to notice that they're going to already, the vector name is already going to be there. And the component form is already going to be there a lot of times. So not always.
So when you look at it, like this example Ms. Hochgrabe is leading into, notice it says the component form of vector RS is 2, -3. So here's the deal. I look at that picture and I don't even see vector RS in there. Does that, like, I mean, do we have to have it drawn in there? Or?
No, and it's something, it doesn't have to be drawn. It's just telling you which direction and by how much.
So really, to me, that first sentence, what's really important, and I'm going to go ahead and circle, it's really that.
Right.
That the vector is describing the component form, and the component form is really telling us, okay, how much and what direction. So if you think about it, what is this component form really saying?
It means I'm going to be going to the right 2 and down 3. For every single point. Just like we did with our coordinate notation.
So if you think about it, you're like, well, how is this any different than the coordinate notation? It's not. It's just the way it looks.
It's just a new notation.
So just get comfortable with it, and if you have, if you have to describe a translation and they don't tell you which form, it really doesn't matter as long as you obviously describe it correctly. So we're using this vector RS to translate, okay, and we already knew it was kind of doing a translation because they said something about component form. The quadrilateral whose vertices are, and they give you all the vertices.
And we've already drawn it on there for you already, too.
Now, does it say anything about graphing this? Not necessarily, but you can, right? But the key in the end, guys, if it does say graph, make sure you do it. But also, what do I need you also give me?
The coordinates of the image. So
I
G
want
prime, H prime, J prime, and K prime.
I want all of these. We want you to give all of those. Make sure you give me the order pairs for all of those. All right, so let's just do it kind of by graphing.
Okay.
And then we can also talk about how we could do it without graphing.
Okay, so for G, we want to go right 2. So 1, 2, and then down 3. Okay, and that ordered pair is going to be at -1, 2.
And I like that you immediately give me the ordered pair because we need that. It's a good habit to get in.
Yes. H, we're going to go, again, right 2, down 3. And there we're at 2, 0 for H prime. And for J, we go, right 2, down 3. So we're at, you're good.
Same.
Yep. So J prime is at 3, 0. And for K prime, again, if we go over 2, down 3, I should say right 2, down 3, it's at 5, -5.
And if I connect these, kind of like how they did, which I'm not
It
real
should
good.
be a congruent figure. Now, obviously, our
So,
drawing is not.
Miss Palermo is not the best at drawing.
Yeah,
here.
neither is Miss Sarah. That's actually not that bad. Not that bad. Okay. Now, you mentioned that there's another way we could do it without graphing. And just like we did with coordinate notation, where we're just adding and subtracting to our x and y values, we could do the exact same thing here.
So what would I have to do to every x value?
Because it's a positive 2, I'm adding 2.
So if I add 2, there's where I'm getting that -1. And what am I doing to the
subtracting
3 because it's a -3, so there's where I'm getting the +2. And you do that for each of them, add 2, subtract 3. You're going to end up with those same coordinates.
Yes.
All right? And that's a good way to also do it if you don't have to graph. This is one where there's not really any pattern or anything like that. It's just using it.
Okay. For our last example, it looks awfully wordy. It says we've got triangle ABC that is mapped onto triangle A prime, B prime, C prime using a translation. So we know that we've got one triangle that's translating to become this new triangle. It's mapped to this new triangle. And they give us the vertices of triangle ABC.
So that pre-image.
So this is my pre-image. And they give me the vertices of my image.
So we're not doing what we just did on the other one.
We are not doing what we just did on the other one.
Okay.
What we're doing here is we're going to write both the component form of the vector and the coordinate notation to describe the translation.
Which we kind of did one like it just a little bit ago, but they gave it in a graph form.
Right.
This one, they're giving you the coordinates already. So we could actually physically graph this if we needed to.
We could.
But let's not.
Probably not needed. And since they don't ever say the words graph and there's not a piece of graph paper on there,
let's try a different approach.
Probably don't need to. Now, one thing that we've been emphasizing is that we're looking at how are we getting from one point's pre-image to its image.
Okay.
Okay? So I want you to look at all these x values and the y values. And we know that we need both component form and coordinate notation.
And I like how Ms. Hargrave is writing that out because when you are asked a question like this, make sure you tell us specifically which one is which.
Yeah.
Right? So component form versus coordinate notation, which one's which.
Oh, goodness.
Now, they should basically mean the same thing because it's the same translation. It's just going to have a different look.
So, like, when I've got component form, I know that here I'm going to want to put my little brackety things. And for coordinate notation, I know I want to start with an x comma y is mapped to something else.
Okay.
Okay? Now, what we need to look at is what's happening to the x value each time.
Well, from -4 to -3, I'm just adding 1.
I'm adding 1.
So it'd be +1.
+1 or a
x plus 1.
x plus 1. Now, it's good to make sure that happens every time. Is that happening every time? Am I adding 1 to get from my x to my y for b's and for c's? Yes. Okay, and then what about the y values?
So I'm going from 5 to 2. That means I'm subtracting 3.
And I would subtract a 3 in any of these cases. So that would be a -3 or a
y minus 3.
That's all we had to do. Okay, so looking at those ordered pairs and seeing what am I doing to get from my pre-image to my image, I can come up with the component form or, again, that coordinate notation. Notice that these look very similar. All right, it's a +1 and a -3. The difference is the notation.
Yeah.
Okay, and
they
that's
tell
what
you
we
the
want to
same
do with.
thing.